Hello, in this video we're going to talk about polynomial division. Now polynomial division can be done in two different ways. Usually we can always do long division, and sometimes in some special cases we can also do something called synthetic division, which is just sort of a shortcut. Alright, so we're going to start out by dividing this four-term polynomial by this binomial. But before we do that, I just want you to take a moment and do some simple long division with just numbers, and so we can look at the similarities. So the first thing that we would do is we ask ourselves, how many times does 3 go into 7, right? And we'd say, well, it goes in twice. Not exactly, but if I multiply 2 by 3, I get 6. So we pick the largest possible one to get that to come close. Then we subtract 7 minus 6, right? And we get 1. Then we carry down that 3, and we start the process all over again. We ask ourselves, how many times does 3 go into 13 now? And this time we'd say, well, it's 4. 3 times 4 is 12, and so we subtract again. It's always subtraction here. I just want you to remember that subtraction. And then we subtract, and we carry down the 8, and we ask one more time. 3 goes into 18 6 times. And because it goes in exactly 6 times, there's a remainder of 0. And because there's a remainder of 0, we say that 3 is a factor of 738. If there was a remainder anything other than 0, then we'd say 3 does not go in evenly, therefore 3 is not a factor. Alright, so the same thing happens when we're dividing polynomials. We kind of hope that we are going to end up with a remainder of 0 and we have a factor, but let's see what happens. So we set it up, looks pretty much the same way. 3x plus 1 into 6x cubed minus 13x squared plus 10x plus 5. Now when you look at this, you want to make sure that your polynomial has no missing degree. So this is a degree of 3, 2, 1, 0. There's nothing missing in the degrees from that. Okay, so we're ready to go. So we ask ourselves the same kind of question. It's a little bit different with polynomials, but it's very similar. We want to know, what do we multiply 3x by to get 6x cubed? We're just looking at that first part. And the answer is 2x squared. And now that we have that, we're going to multiply the whole binomial by that 2x squared. So 2x squared times 3x is 6x cubed. 2x squared times 1 is 2x squared. Now, the next step is we subtract, right? 6x cubed minus 6x cubed is 0. Negative 13x squared minus 2x squared, or subtracting, is negative 15x squared. And then what did we do before? We carry down the next piece. So in this case it's a term, but we carry it down nonetheless. And then we're ready to start the whole process over again, and we ask ourselves, what do we multiply 3x by to get negative 15x squared? And that is negative 5x. So we put that on top, minus 5x. And then we multiply it out, just distribute that negative 5x, we get negative 15x squared. And then negative 5x times 1 is minus 5x. Okay, and this is where a lot of students will make a mistake. Subtract here. Don't forget you're subtracting. So 10 minus negative 5 is actually adding, right? It's 15x. And then we carry down the 5, plus 5. And then we do the same thing again, and this time we're adding 5. And we multiply 5 times 3x, we get 15x. 5 times 1, we get 5. And this time, when we subtract, we get 0. So that means there is no remainder. And so our conclusion is 3x plus 1 goes evenly in to that four-term polynomial, and therefore 3x plus 1 is a factor. Okay, so we can write it. We can write the original polynomial now in factored form. It is, I'll just write the whole thing. Okay, 6x cubed minus 13x squared plus 10x plus 5 is the same thing as 3x plus 1 times 2x squared minus 5x plus 5. And we have factored something that started out as a polynomial. Now it's 2 factors. Okay, if we could factor this piece further, we would, but we can't. All right, let's go on to the next example. let's just do the same thing. I'm going to set this up. So x minus 1 goes into, now notice this time there's a missing term. There's no x to the fourth term. So I'm going to put in 0x to the fourth. So I have 8x to the fifth plus 0x to the fourth. Doesn't matter if you say plus or minus, it's 0. So minus 14x to the third plus 9x squared minus 7x plus 4. Now let's see if this one also goes in evenly. First we ask what do we multiply x by to get 8x to the fifth, and that is 8x to the fourth. Right? 8x to the fourth times x is 8x to the fifth. Now we distribute that 8x to the fourth over both terms in the binomial, and we get 8x to the fifth minus 8x to the fourth. Then we subtract. We get 0 here. Subtracting 0 minus negative 8 is positive 8. So we have 8x to the fourth. Carry down the 14, so minus 14x cubed. And I'm going to ask you to pause the video, see if you can finish up the process, and then we'll compare. Okay, so we do get a remainder of 0. That means x minus 1 is in fact a factor of that fifth degree polynomial. It goes in evenly, and that means that we can write that fifth degree polynomial as the factor x minus 1 times 8x to the fourth plus 8x to the third minus 6x squared plus 3x minus 4. Alright, so that's it. Now I'm going to show you a shortcut to this that you can only use when you have a factor or a divisor that's in the form x minus c. You don't know if it's a factor at the beginning, and if you get a remainder of 0, then you know. Okay, but this time we do know that it's a factor. So here's how you do it. You take the 0. So you know that since x minus 1 is a factor, you know that x minus 1 equals 0. Okay? So we can now take that 0. So x equals 1 is the 0. So we put that 0 up into the corner. Then we take all of the leading coefficients. Don't forget the 0 here. So we take all the same coefficients, but we just don't need all those x's. It's just going to be a shorter way of doing the same thing. So we have 8, we have 0, we have negative 14, we have 9, negative 7, and 4. All right, so we put this line here. Now I made the line so that there's a gap between the 8 and the line and the 0 and the line. There's this gap because I'm going to fill in some numbers on there. So let's go ahead and do the synthetic division. Here's the process. This is how you set it up. Now here's the process. You always start out by carrying down that first number that's automatically always going to be there. Carry it down, then you multiply it by the 0, that 1. So you get 8 times 1, which is 8. Then you add. 0 plus 8 is 8. Then you multiply by that 0 again. So 8 times 1 is 8 again. Then you add. Negative 14 plus 8 is negative 6. Then you multiply by the 1, so you get negative 6. Then you add, so you get the 3. Then you multiply, you get 3. You add, you get negative 4. You multiply, you get negative 4. And you add, and you get that same remainder of 0. Now, that's a lot less work, but the conclusion is the same. What we call these are the coefficients of a depressed polynomial. Depressed means it's down, it's lower by one term. So this is a polynomial that instead of starting out at 5th degree, this starts out at 4th degree. So this would be 8x to the 4th plus 8x to the 3rd minus 6x squared plus 3x minus 4, and that would be multiplied by the factor that we, the divisor that we now know is a factor, x minus 1. Okay, same answer, different process. You could actually do that with this problem up here, but I kind of don't recommend it because since 3x plus 1 is a factor, that means that 3 times x plus 1/3 is also a factor. So you could have done the 1/3, and the only thing is we have to remember at the end to divide whatever we get by 3 because we multiplied by 3 up here. So you could have done the same process, and I'll just show you what it looks like. So there it is. You still get the same answer, but notice that going from here to here, I had to remember to divide that 3 back out. That's why I don't recommend it. Sometimes it's easy to make a mistake forgetting to divide that 3 back out in the end, and then you end up like second guessing yourself and end up still doing the long division just to make sure you got it right. So it's not that much more work, but it is an option. Okay, let's look at the last example, and let's just go ahead and set this up and see if x squared minus x plus 1 is a factor. Okay, so this divisor is definitely not in the form x minus c. So in this case, we really have no option except for long division. But the process works the same even though this is a trinomial. So we start out by asking, what do I multiply x squared by to get x to the 4th? And that is x squared. Then we actually distribute that x squared over all 3 terms. Oh, I missed something here. I noticed I missed a 0 x squared. So I'm going to just fix that before I go any further. So I have x to the 4th minus 3x squared to the 3rd plus 0x squared plus 2x minus 5. Okay, that just makes it a little bit easier to see what's going on. All right, so I have x squared times x squared is x to the 4th. X squared times negative x is minus x to the 3rd. And x squared times 1 is plus x squared. Let's subtract. So I have x to the 4th minus x to the 4th is 0. Negative 3 minus negative 1 is negative 2. And 0 minus 1, 0x squared minus 1x squared is negative x squared. And let's carry down that plus 2x and go for round 2. What do I multiply this by to get negative 2x cubed? Negative 2x. So I'm going to subtract 2x. Alright, so then I distribute it. Negative 2x times x squared is negative 2x cubed. If you don't get a match in that first term, you chose the wrong term. Negative 2x times negative x is plus 2x squared. And negative 2x times 1 is minus 2x. Now we're going to subtract. Don't look at this and see a 0 here. This is a 4x, but this is a 0 over here. Negative 1 minus 2 is negative 3x squared. And 2 minus negative 2 is plus 4x. Carry down that minus 5. And the last round would be to multiply by negative 3. So minus 3 here. Distribute that negative 3. We get negative 3x squared. Negative 3 times negative x is plus 3x. And negative 3 times 1 is minus 3. It looks like this one has a remainder, and so x squared minus x plus 1 is not a factor. When we subtract here, we get 0, we get x, and we get negative 5 minus negative 3, which is minus 2. That's a remainder. So that means that what we have here is we have the divisor x squared minus x plus 1. Actually, I'm just going to write that as when we divide the 4th degree by the 2nd degree, we end up with x squared minus 2x minus 3 plus x minus 2 over the divisor x squared minus x plus 1. That's a remainder. It's not 0, and therefore x squared minus x plus 1 is not a factor. Okay? Okay, let's hope you found this helpful.